MB95, what's happening? And Shri J Anths, what's happening? Did I say that right? I probably didn't say that right, man. From YouTube. Uh, anyways, hold up. Do I teach data structures and algorithms? I don't normally teach. I guess I can teach. Do you have any questions? Hey, Howlin, what's happening? How you doing? Welcome to the party. Sometimes I teach, man. Sometimes it's like somebody in the chat has a question, or if they ask me to go over a certain algorithm, I'm always like more than happy to do that. So I guess I do teach, but I don't have like a scheduled like lesson or a structure. Um, Everybody on Twitch, I'm talking to somebody asking on YouTube chat. I know it's not on the screen or anything. Well, that's what I'm doing right now. How's it going? It's chilling, Howlin. How's it going over there, man? I've just been doing a little vibe coding, man. Trying to get Type Blazor up and running. And I feel like I'm really close to where I want it to be. You know, I've been like working on it basically for a whole month, and it's finally coming together, you know. But anyways, it is algorithms practice time. We're not trying to vibe code right now. Here we go. Here we go. I just audited my code base after vibe code in 2 weeks. What do you mean audited, like manually audited, or you told your agents to go audit your code base? I haven't audited anything manually. I asked the agent to audit. Yeah, that's what I'm talking about. I was about to say, dang, you're crazy, man. I guess it's not that crazy to want to actually manually go in there and audit. But yeah, I think I try to audit every couple weeks or so, because it does get wild in there, man. There's some questionable decisions that the AI makes. Um, I'm really new to DSA. Where do I start myself to landing big companies? I'd say if you're new to DSA, you should familiarize yourself with maybe some data structures first, like arrays, strings, integers, stuff like that. If that's too basic, then start looking at queues and stacks and other things. And then maybe start to like do each algorithm topic by topic, man. Like just pick one of those topics and just do those problems and read about the topic, try and understand it, and then just keep doing that for the rest of the 25 or however many different topics there are. So if you spend like a couple days on each topic, it's gonna take you like 2 or 3 months at least. Javier D, welcome to the party. All right, what are we trying to do, man? We're trying to do LeetCode here. Wait, like stuff work, but it's questionable. Yeah, might be. It's questionable, he says. It might very well be, man. Let's do the daily problem first. Find kth bit in nth binary string. What does that mean? Given two positive integers n and k, the binary string sn is formed as follows. If s1 equal to 0, or si is equal to s1, or si minus 1 plus 1 plus the reverse of the invert of si minus 1. Alright, where plus denotes the concatenation operation, reverse returns the reverse string x, and invert inverts all the bits in x and changes to 1 and 1 to 0, or whatever. 0 changes to 1 and 1 to 0. All right, these are the first 4 strings, and then we gotta return the kth bit. And the kth, dang. Which one? All right, maybe we can do it. Maybe we can't. How is life outside of the zoo going? Javier D, what are you talking about the zoo, man? You talking about my zookeepers no longer feed me zoo steaks? Hey, Zombie Chow, how you doing, man? Welcome to the party. Life outside the zoo is pretty good, but I have to still worry about the dang where I'm gonna get my next zoo steak or my next meal from, you know. All right. Zoo steaks. You guys eating good out there, huh? I don't have no zoo steaks anymore. All right. So they give us the first few, and they say if n equals 3, we gotta find the kth bit. Man, that sounds too hard. Oh Jesus! But look how many people got this one right. Let me look when I solved this. Dang, I solved this 2 times. 2 times in my life I've solved it, and I solved it when I first started to study, man. So how hard can it be? Right? It can't be that hard. It sounds like we can do it. So let's just try and focus on it for a little bit. What is n here that they give us? And it's like how many times si, right? Or whatever. And then the kth bit is which bit is, yeah. So each thing, it is the previous one plus 1 plus the reverse of it. So each time it gets doubled and 1 is added to it. So the kth bit, I don't know. We're gonna have to try and science this one out, man. Do I just generate all the things and then just return the kth bit? Can I do that or no? I can't do that because it'd be too big. So I need to figure out the pattern or something. How can we do it, man? I don't like these problems. I'm not gonna lie. I don't like the problems that don't have like an algorithm that's just falls into a category. And you gotta like think outside the box. It's too much. All right, let's try and think outside the box, man. What's going on here? I know every iteration it doubles and you add 1. That's one observation I can make. So why do I care about that observation? I'm not sure yet. But it's safer to think inside the box. Brent Arata, how you doing, man? Leet Whale is also in the house. How you doing, Leet Whale? Man, what list is this saved on? Who knows? Stressful day. Dang. Sorry to hear that, man. Alright, kth bit. So we know what k would be. 2 to the n minus 1. And then maybe, depending on which side of the half it's the k's on, maybe from there we can figure it out, because in the middle there's supposed to be a 1 always, right? In the middle bit. So this is the middle bit. The length is always going to be an odd number, right? Middle bit is always 1. And then from there, maybe we can determine what the k thing is. Dang. First things first, maybe I can just all right, if this ran 20 times, how big would that number be, man? Do we have to go all the way up? Can we just run it? I feel like we can probably just run it, man. Should I try? Maybe I should try like call it half. And then we only need to go up to say 19 or 20. 20 can be constructed from the n minus 1. How many things would that be, man? 2 to the 19th? Man, I could probably hold that in a string, huh? It doesn't even need to be a string, like a vector of booleans. I don't know what to do. I don't know what to do. But I'm tempted to just try this to see if it works. So maybe I start from I equals 1, and then start with our string just being 0. So then 1, this would just be equal to half plus 1 plus reverse. What do they want? They want the reverse and inversion of si minus 1. So maybe I should name this like previous instead of half. Alright, what's happening? JV Shandan, how are you doing? Welcome to the party. Blue Cactus AI, how are you doing, man? This one is tough. Yeah, I don't know what the hell to do in this one, but I've solved this twice before, so I'm not too sure, man. It seems kind of hard to me still. Steven Saggyball is in the house. What's happening, Steven Saggyball? All right, how do I inverse something? How do I inverse something, man? It's too much. Should I make a function to do that? I will. And should I do it like in place as well? Let me think. Just sagging it up. Yeah, very, very cool, man. Hey, how do I do this though? Should I have this replace S in place? Maybe I should call this inverse and reverse. Should I do something like that, man? I don't know. Maybe I'll just have it return a new string, and then we'll see how that goes. So we want to reverse it, right? Reverse ret.begin, and then we want to inverse it. So for every character in ret, I don't know if it's a 0, turn it to a 1. I don't know how to do this. Maybe there's a nicer way to do this with actual characters. So I'm gonna just call inverse and reverse that. Man. Can I do that? We'll see. And then, man, am I just gonna hit them with, hold on, prev equal cur. Should I have this here? And then I can just change it there, so then we can just access it at the end. This can't be right, man, because if this is how I solve it, I guess that's probably why it has a 70% acceptance rate. OpenAI evaluation is insane. What is it, man? I don't even know what their evaluation is. Let me see what S3. That looks like that, yeah. But then they're saying what? K is 1. So they want, man, they want the K K minus 1. It's like 1 index. Come on, man. 730 billion. I don't know how to value confidence, so I don't know if it's insane or not. Dang. So I guess that's why this feels like not the way it's intended to be solved, though, whatever I did here. Look, it even passed with my C out in there, you know, so I guess it was only one time per call. It wasn't like in a loop or anything. But either way, man, I think it feels like there should be a more clever way to solve this. Not very proud of this solution, but it works, so whatevs, right? All right, what are we gonna do, man? Hey, Steven Sagiball, do you still LeetCode? When was the last time you did a LeetCode problem? I'm gonna do the dang contest that I just missed. Where's that at? Weekly contest 491. When I was interview prepping, man, that was a long time ago now. At least a year. Here we go. Weekly contest 491, just last weekend. We'll see how many I can do. Shareholder value 10. First time chat, what's happening? LeetCode in the big 2026. The new LeetCode is now how many Claude agents you can run in parallel to increase shareholder value. We are shareholder value maxing, man. That's why I train both, man. I train algorithms to keep my brain sharp and just to keep ready, just in case I need a job real quick. And I also train how many Claude agents I can run in parallel at the same time, man. I do that. I train Claude stuff 5 times a week, maybe 6 times a week, and I train LeetCode 3 times a week. And this is one of my 3 times I'm training right now. Mondays, Wednesdays, and Saturdays, LeetCode. Here we go, virtual contest 491. Question 1. Trim trailing vowels. You're given a string S that consists of lowercase English letters. Return the string obtained by removing all trailing vowels from S. The vowels consist of the characters A, E, I, O, U. All right, here we go, man. I'll just make a little thing here. That's gonna give me the right answer. How do you do a lambda again? It's like that. So if it's A, E, I, O, U. We're gonna, can I do that? Yeah. So while the last character, well, like while there's something in there, while it's not empty, and the last character is a vowel, we're gonna pop back. And that's it. Dang. What is going on here? No semicolon. So I should get ID, day, and blank. So ID, day, and blank. Sending it. Easy work, Q1, Q2. Minimum cost to split into ones. You're given an integer n. In one operation, you may split an integer x into two positive integers, a and b, such that a plus b is equal to x. The cost of this operation is a times b. Return an integer denoting the minimum total cost required to split the integer into n ones. The integer n into n ones. Dang, what? Everyone vibing until they need that LeetCode to get the job. Yeah, that's what I'm saying, man. Companies still asking LeetCode, so you know, if that's how they're gonna filter all the vibe coders out, they only want the best vibe coders who can also LeetCode, man. That's how it's gonna be. All right, how are we gonna do this? Ooh, n is only 500. So I split it into two things such that a two parts equal that. So to minimize the cost, it would I'd say, man, to get the minimum cost, it's always gonna be 1 plus or 1 times a really large number, right? So like 1 times 499 and then something like that. Right? All right, so let me try that. And then how many? I'm gonna say total cost. I don't know how many times we have to split that into. I guess n times, man. N times. So if it's 500, it would be 500 ones. Let me just double check what they're talking about. What the hell is x, man? A, B. Oh, the number x is n. I don't know why they use x when they say n here. But n is 3. You split 1. You split 1. So now you got 3 ones. Yeah. So if n is 3 here, you do 2 splits. So I guess this would be like I less than n minus 1. So it's just, man, it's just n minus 1, man, right? Or, no, it's just n. Nah, am I tripping? No, wait, we want the cost. We want the cost. What is the cost gonna be? Actually, I don't know, man. It's just gonna be it's just gonna be 1. Wait. hold on. It's just gonna be n minus sum of natural numbers. I don't remember the formula. Let me see. Am I doing this too many times? One. Wait. Let me think. Am I off by one? Because I'm just trying to sum two. All right. Come on, man. Come on. I see. Wait. I think I know what I'm doing, man. It doesn't look like it, but I think I know what I'm doing. But so n is 3. I'm trying to do n minus I minus 1, so that's cost of 2, and then do it one more time. So it'll be n. This should be all right, man, but it's not. What am I doing wrong? I don't know what I'm doing wrong. If this was a real contest, I'd be panicking right now. Ooh, maybe I should start at 1. Maybe that's the problem. All right, 3. Whoa. That's not right. Jeez, maybe it was right, man. Hold on. I was looking at the wrong test case. Look at that. That's right. And that's right. I should have sent that a long time ago. I was looking at the wrong test cases and confusing myself. So I don't want to oversend it and then get like an overflow or something. But I think we'll be good. I'm just going to send it. Too easy, man. It's like so easy. It made me question like if what I'm doing is right. Anyways, Q3. Minimum bitwise OR from grid. What? You're given a 2D integer array grid of size m by n. You must select exactly one integer from each row of the grid. Return integer denoting the minimum possible bitwise OR of the selected integers from each row. Minimum possible bitwise OR. And we have a lot of grids, man. Up to 100,000 cells in our grid. And so, all right, how does an OR work? A bitwise OR can never shrink. It can only grow. Yeah? Like, if you OR 2 numbers together, it will only get bigger. So, we need to figure out a way to select the least amount of bits that how much their values add up to. How are we gonna do that, man? Interesting. I don't know how to solve this one immediately off the top of my head. I'm thinking some type of take it or leave it on every single cell. That's the only thing I can think of, man. You just take one number from each row and you try like take it or leave it. You go to the next row, you take it or leave it, and you just do an OR all the way down, and then you remember the minimum number that you've reached when you hit the end. Yeah, and then you cache on I and J, and that's it. I think that's what I'm gonna try, but I don't really know. Minimum of each row. I imagine there can be a test case that minimum of each row might not work. But yeah, I can imagine many test cases perhaps. Let me think. So like if these are binary representations, let's say we had, that's one number, but then minimum of each row. Like let's say this is one row, this is another row, these are all rows. Or yeah, these are all rows, right? And if we took the minimum of each row, would that be good? I don't know. Like, what if it was like this? If we took the minimum for each row, that wouldn't work, right? Or would it? No, that wouldn't work. Anyways, I think I'm gonna try a take it or leave it on every cell. And then we'll see. So that's how many rows and columns we have. Let me make some type of DP. Is it DP? I guess so. So the row and our, do we need a column thing, man? I don't even know if we need column. Let me give it some more thoughts. Yeah, I think we do need column, man. I think so. All right, how is this DP thing gonna work? It's gonna like, we're trying to hit every single row, and for each row, we're gonna select only one index and then move on to the next row. Man, what else do we need then? Let me think a little bit more. Feels like, man, I gotta really practice my 2D grid DP stuff, man, because it always trips me up. I'm not trained enough right now. But if I select one, I want to just go to the next row. So it'd be like R+1. But do I need this C thing, man? I don't think so. So if we go out of bounds, we should just return 0. Yeah? Yes. And then now we should go through each thing. So each column, I guess, in that row. And then we're going to try to choose that cell. What does that mean, to choose a cell? I don't know, man. It means, man, what does it really mean? Let me think what that means. It means that we're XORing something. So I'm trying to get the minimum number. And I have to, not XOR, I gotta OR it with a number. Q Ultimus, what's poppin', man? Wait, what do I do here, man? Maybe I go like grid RC or DP R+1. So it's like it gets the minimum from the next row and then ORs it. And then I gotta return the, what do I return here, man? Wait, I think I'm tripping myself up. Let me think. Did I miss Q2? Yeah, you missed Q2. Q2 was pretty quick for me. Um, this one I feel like I can do, man. For sure, I feel like I can do Q3. But I'm just tripping myself up. I think I need my C. Do I need the C for caching, man? That's what I'm trying to think of right now. No. Alright, I think I'm just gonna continue. Did you use sum of natural numbers or DP? For Q2, man, I just brute forced it. How do I go back to my Q2? I guess it was sum of natural numbers then. But I brute forced the sum of natural numbers. Because I didn't want to think how to do it, man. I was afraid of off by ones and stuff. Alright. I can do this, man. I can do this. I use DP, dang. Sounds crazy, Q. Let me think about this stuff here. All right, actually, let me stop thinking about this. Take it or leave it, man. Let me like try to explore some other options before going down this path because I'm not even too sure about this. I think it's kind of tripping me up, man. So let me take a step back. All right, here we go. What do we know? We know that if we take an OR of something, it can only grow. So we'd want, if we had a bunch of numbers on each row, we had to pick one from each row. How do we know what is the minimum we can get? It must be DP, man. I can't think of any other way, man. We gotta try them all. But I'm alright. Where my mind is breaking down, like why I'm so hesitant. It's like I don't even know what the cache results mean. Like if we take the minimum answer for one row, doesn't mean we can just use that answer for our current row because it could be different. So I don't know. That's why I'm trying to like go back to the drawing board. Maybe I'm tripping myself up, overcomplicating things right now. Let me take a peek at Q4 real quick. Count subarrays with k distinct integers. No, I'd rather go back to Q3 and think a little bit more about Q3. What is this? I know this you. Hello, bro. I'm from India. And you? What's happened? I'm from Jamaica, but I'm not in Jamaica right now. I'm somewhere that I haven't said, man, but I'm just here to do LeetCode. I'm from the internet. let me think about this problem, man. So all right, let me look at these examples. Choose 1 from the first row and 2 from the next row. The bitwise OR of those two is 3, which is the minimum possible. Let me think. What is your opinion about AI? I don't know. I think it's very interesting. It's definitely fascinating where it might lead to. I don't know. It's cool. It's not cool at the same time. What can I say? I don't really have a strong opinion. Just choosing which number, man. Let's see. Why wouldn't the minimum of each row work? Look at this one. Example 2. If you chose a minimum, it would be 3 and 4. Let's look at what those bits are. So 3 in binary is 1 and 1. 5 in binary is 1, 0, 1. So this is the first thing, and then this one is 6. 6 in binary is 1, 1, 0. And 4 is, what is 4? 1, 0, 0. So if we chose a minimum, so this is 3, and this is 5, and this is 6, and this is 4. If we chose 3 and 4, that will give us 7. The XOR of this and this, it's 1, 1, 1, which is 7. But the answer is you choose 5 and 4. It's sum. What you talking about? What do you mean it's sum? I am second year computer science. I'm very terrified because everyone say AI will take all jobs. Hey, that's a possibility, man. But what can you do? Life goes on, you know. You gotta adapt. You gotta do something. You gotta pivot, or maybe AI doesn't take all your jobs and you'll be just fine. Maybe just stay the course. But you'll figure it out, man. I'm sure you'll figure it out. Everyone is gonna figure it out. They have overlapping bits, yeah. So, all right, how do we come up with an algorithm to solve this, man? They say this one is 5 and 4. How are we gonna solve it? Let me think. It must be. Is it like a? I don't know. I feel, all right, it must be some type of take it or leave it, or would that work? Is it like a trick problem? There's 10, or there's 100,000 cells. Each cell is up to 100,000. I don't know. You could BF XOR them and get the minimum of those results. I'm not sure what you mean. Give it some more thoughts. Krishna, how you doing, man? Hey, I've just started a contest. What the biggest piece of advice you'd like to give me? Because sometimes I just lose hope that I can never solve more than 2 questions without any error. I'd say biggest piece of advice, if you're already solving 2 questions, man, you're doing pretty good. Biggest advice would just be keep on keeping on. Don't lose hope. Keep practicing. Sometimes it's hard to see how much progress you've made when you just look at the results of a singular contest. Or even sometimes you have slumps, man, or you have a row of like unlucky contests. So I wouldn't over-index on your contest performance. Those are random, man. But what you can try and focus on is think about how many problems you're able to solve today and how many problems you were able to solve a month ago. And if that number is more today than it was a month ago, you're doing great, man. And you should just keep on keeping on. I think this has a fun solution. Brett, how you doing, man? This solution is fun, you say. I'm still trying to think about it, but it's feels tricky. I don't think DP is the way, because I just can't make sense of that relationship between the rows, you know? Like, the best answer for one row could completely change with the new information from the new row, you know? I think it can. I don't know how to prove that, but I just have a hunch. Maybe an idea? You want to give me an idea? Yeah, I'll take hints. I'll take hints right now. For the scenario you showed before, it's not XOR, it is OR. So it's not the XOR, it's the bitwise OR operation. Solve it 20 times. So you're saying, let me think, solve it 20 times. What does that mean? That means based on the number, we should focus on each bit. Focus on something with each bit. Let's focus on those things. Like this, you're saying this constraint is a hint. Wait, is that what you're saying? 2 to the 20. No, that's maybe not what you're saying. Wait, maybe that's what you're saying, bit by bit. Bit by bit. I'll leave it there for now. All right. Wait. I'm also solving problem in LeetCode, but I don't do because I can't make consistency. I can't think about test edge cases, so it leads to errors. Hey, that's fine. You'll learn from your mistakes eventually, hopefully. Sometimes you'll probably notice the same test cases that always mess you up. Like, you know, and then you'll get the hang of it. Maybe you just lack some experience right now. Wait, Brett, let me think about that bit by bit. So these are having bits here. So if you're saying bit by bit, solving it 20 times. So you're saying we try and find the minimum position in a bit by taking each thing one. Oh, hold on. Something, I'm visualizing something, man. I can't put it into words just yet, but I see a vision, man. And it's looking like, what is it looking like? It's looking like I single out a bit from all the numbers in a row. And then I take the AND of that, because and of all of those numbers, because if there's 1 0, that means we can select that bit to be 0. No, I don't know what I'm thinking, Brett. I think I'm tripping now. But if we solve that for each bit, what does that mean? Could you compute what the most significant bit of the solution is? So the solution here is 3, or no, the solution here is 5. Most significant bit of the solution? I don't know if I could compute that, man. Yeah. Let me think. Because this one, it's like you gotta select something. For the first row, you can get away with the second bit set. Hold on. The first row, you can get away with only the second bit set. Oh yeah, so this bit, you can get away with that. 3, yes. The second row forces the third bit to be set. Are you saying it forces the third bit to be set because by the time you get there, it doesn't matter which choices you made? No. Does it? I don't follow you. Wait, because both 6 and 4 have it set. Wait. I think I'm confusing myself though, man. Vix TH, what's happening, man? Thank you very much for the follow. It doesn't matter what you choose in row 1 because they're. Wait. Oh, because you said third bit. Yeah, the third bit is always set. Yes. I follow, man. So it doesn't matter what you choose in the first row. Once you get to the second row, this bit must be set. So is that the most significant bit, whichever row has all those numbers set? That's crazy. Yeah, so you know the answer will have the third bit as the most significant bit. Correct. So you're saying with this knowledge, I should be able to come up with a solution. I think I see where it's going, man, but let me try and finish it up. So, man, it's still tripping me out though. I don't know. Select anything. The most significant bit is obtained by the computing the best in each row and then the worst over all rows. I gotta think about that, Brett. Might have lost me there. Computing the best in each row. I don't know what the best in each row means. Wait. Oh, the lowest number in each row. So you're saying take the minimum of each row, kind of what the other JW01 was saying in the beginning, but it's not quite that simple. No, not the min of each row. Minimum worst bits. Huh. Alright, best in row 1 is the second bit. Worst is, okay, I think I see. Yes, yes. Minimum worst bit. 3 is better than 5, yeah. Minimum worst bits. So let me go back to your comment here. The best in each row. Alright, the best would be this bit. And the best bit in this row would be 4. Or I think I'm confused, Brett. I don't even know, man. How do you think of these things? 6. Oh, they're tied because though I see how that's tied. Yeah. Because that one tripped me up, man. I was like, what's going on there then, huh? All right. All right, but if we have this bit set, I don't know still. I'm sorry, Brett. This problem is tripping me out big time. So you're saying, wait, the minimum value would always be the best pick, wouldn't it? Yeah, it would not. In example 2, man, we went over this earlier. Example 2 is a case that breaks that. So all right, this one says you take the 5 and the 4, but the best. All right, you say the best in row 1 is the second bit. Best in row 2 is the third bit. And then the worst. Best in row 2 is the third bit. Worst of second and third bit is the third bit. Yeah, that's the worst. The minimum worst. So after step 1, we know the third bit is set in the answer. Now we try to optimize the next bit. Oh, dang, that sounds tough, Brett. Is that the only way you can solve this? It's so trippy. All right. We realize the third bit is always set. And then you go to the next bit to see if we can get away with not setting this, like the second bit. And how do we see that, man? We see that there's zeros here or something. A count of zeros is high. Now you can see in that bit, all of them is one thing. So for sure, we can always skip not setting that bit. Right? And then this bit, we can see like we're absolutely have to set that bit. So you're saying we go bit by bit and we just do an AND on every single bit in that position? Kinda? Or no, that can't be right, man. Can it? Who knows? No, it can't be right. Wait. I want to see how low we can get the next bit. I can try and implement that, but I have my doubts about if I'm understanding it correctly. For sure, I know what you're saying is probably right, man, but I just can't see. Maybe I might missing the connection. I agree that this is a bit tricky. Yeah. A bit. Are you trying to make some puns, man? It's a bit tricky. All right. Bit by bit, huh? No, I don't think I can do this one, man. I have to see. Let me look at a solution. I can't. My brain can't work on this problem right now. And then I guess Q4 I can't solve, man. Q4 is probably too hard. So I've only gotten Q1 and 2 for this contest, realistically. Which is not that great, man. Dang, look at that, 22%. It's crazy. But so many people got it on the contest. Super easy, this guy says. Oh, here's Lee215. Always at the crazy solutions, man. Let me look at this super easy guy. I just want to see the code, I guess. Or maybe it doesn't. All right, this guy's also checking each bit, man. So you go through all the bits. I don't even know what he's doing, but something bit by bit for sure. Anyways, start from the most significant bits. Who knows what this is saying, man. I don't want to actually read any solutions. Maybe one day I'll revisit this problem. And maybe I will, maybe I won't, man. Alright, what do I do now? Let's do elite rooms, because I think I'm running out of virtual contests to take. Everything's too hard for me these days with LeetCode. Elite rooms, let's hit all mediums, man. His code is nice. Yeah. Maybe I should have paid a little bit more attention to it. I don't know. Oh wait, I made one with easies. I meant to make it with easy or only mediums. Only mediums. Dang, what kind of low problems is this giving me? Is that can't be random, can it? I'll try one more time. Alright, that looks more random. We definitely missed all the championship race. Dang. Nobody reminded me. I'll try and remember the next one. Let me go on the thing so it makes a beeping sound, man, for the championship race. Did everybody miss it? No. Clistar didn't miss it. Alright, Type Blazer championship race. My browser will make the noise next time. Alright, let me pin this. And let me send it on YouTube. Here we go. Q1 is longest word in dictionary through deleting. Given a string S and a string array dictionary, return the longest string in the dictionary that can be formed by deleting some of the given string characters. If there is more than one possible result, return the longest word with the smallest lexicographical order. If there is no possible result, return the empty string. What? So they say this is our string, our dictionary is this, and the answer is apple. Longest string that can be formed by deleting some of the given characters. I see what they're saying, man. So we need a frequency map of S. Brett and Leetwhale are in the house. Here we go, char. We need a char count, basically. Right? And then what are we gonna do next? Basically, we gotta go through the dictionary, all the words in our dictionary, and then we gotta create a frequency map for that thing. And then now, what do we gotta do? We gotta just make sure that there's enough letters in our original frequency map to create that current character. So I'll try and do that here. So I'll go through. Man, it's gonna get. I guess we can use C again. For every character and count in our current map, we need to make sure that the frequency of that character is greater than or equal to count, otherwise it's bad. Wait, so what did I just type, man? If frequency is greater than equal to it, then this is good. Otherwise, it's bad. So maybe I should have put less than, but I'll just leave it like that for now. And then if it's good, then hold on. I need an answer. I'll default the answer to the first thing in dictionary. But then I'll also make another boolean called found good or something. No. Jeez, what should I do here for this answer, man? Let me think. Oh, I know what I'll do. I'll just make a bunch of Z's, man. That's what I'll do. And then here, it would be for that word. Yeah, I think this is good, man. Wrong answer, jeez. Ale expected apple. Let me think here. Return the longest string in the dictionary that can be formed. I see. That's where I messed up. So, alright, if ans.length is less than alright, else if the lengths are, I'm comparing the lengths to decide what to do. Anyways, what is this, man? Word.length. Oh, come on. Come on. Why is this not right still? So if that's greater than, maybe I'm saying we can make the word ale. Hold on, did I misunderstand the problem? Oh, wait. I think I have this the wrong way. My bad. So maybe here I'll just have an empty string actually. I just misunderstood the dang thing that they're asking. I think this should be alright. Took me too long to get it wrong, man. Let me think. Why did I get it wrong? Because we can't make that word. Let me read the thing again one more time. Longest string in the dictionary that can be formed. Am I tripping, man? Why can't we make this? Because there's not enough. There's a A. Do they have to come in the right order, man? Maybe that's what I'm messing up. It's like the order that they come in. Man, this problem is giving me a lot more. Yeah, I think I've just approached it completely incorrectly. Where you can't just delete characters like that. You have to make sure they're in. We have to make sure it's a substring, man, not just whatever you call this shares the same characters. I think that's where I messed up mainly. So I'm just going to restart, man. Messed up big time there. Maybe I'll make a function is substring. Sir Lord Good, what's happened? Simon, are you able to solve hards? I would say only a few hards I've solved, man. I'm not very good at hards. I have solved in my whole life 121 hards, which is not much. Most of the things I do are mediums, man. I think mediums are fun for me. Hards, it's like, it takes too much thinking, man. Or maybe for me it takes too much thinking because my skill level. I'm missing a lot of the algorithms that you need for hard problems, I think. Alright, here we go. What was I trying to do? I was trying to do check substrings. So how do I know if it's a substring? S would be 1. I don't even know how to do this. So if that equals that, the characters are equal, we should increment both. right? Otherwise, we should increment I. I think that's it, man. So for everything, I'm gonna check if it's a substring. So if is sub, if the length is less than the word, we should set that to our new answer. But if it's equal, then we should take the best one. And I don't think we need this anymore. And I'll see if that's good, man. That problem took too long. I went down the wrong path in the beginning and didn't take me, or I didn't realize I was doing the wrong thing until it was too late, man. All right, next problem. What we got next? Minimum cost to make array equalindromic? What kind of word is that, man? You're given a zero index integer array nums having length n. You're allowed to perform a special move any number of times, including 0 on nums. In one special move, you perform the following steps in order. Choose an index I in the range 0 to n-1 and a positive integer x. Add the absolute value of nums I minus x to the total cost. Change the value of nums I to x. Dang, this problem sounds hard. A palindromic number is a positive integer that remains the same when its digits are reversed. For example, 121, 2552, and 65756 are palindromic numbers, whereas 24, 46, 235 are not. An array is considered equalindromic if all the elements in the array are equal to an integer y, where y is a palindromic number less than 10 to the 9th. What kind of problem is this, man? Return an integer denoting the minimum possible total cost to make nums equalindromic by performing any number of these special moves. All elements in the array equal to an integer y. All right, let's see. So the answer here is 6 because, man, should I even attempt this? 23%. Sounds crazy. All right, so for every index, in one move, you can choose an index and a positive integer, any number, and then you add that to the total cost and you change that number to x. So you add the difference. So basically, we can change any number to any number. The people that write these problems got big brains. Yeah, something like that, little pixel. I don't even really understand the problem yet. Should I skip this? One's crazy, man. If LeetCode can't solve it, I can't solve it. Everybody knows that. All right, let me try and just figure out what the problem is asking. So this one, they want us to change it to 333. Minimum cost. So I wonder if we have to calculate all palindromic numbers and then figure out which one is best. I wonder if this is like a median type problem where you take the median. So the median of this would be 3. TV Josh, what's happening? Which problem is this? Yeah, this problem is crazy, but it's this problem. Alright, is it a median thing? Alright, let's look at example 2. The median would be 13. So 3 plus 1, 4, 5. No, it's not. No, because 13 is not palindromic. I wonder if we have to generate every palindromic number up to 1 billion and then do some type of binary searching maybe. That's my thoughts here. How many palindromic numbers can there be? I suppose a lot. So up to 1 billion. Feel like there should be a lot. Should we try and write a few down? Maybe we can identify a pattern. So every single number itself is palindromic. Oops. And then the next one would be 11. And then what? 2, 2, 3, 3. Is it like that? Those are the next palindromic numbers, and then it's is it like that? Alright. Alright, 1, 2. Those are the first palindromic numbers. Then we got these. Man, I messed up by putting them on different rows like that. Then we got these. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. But then we got no. I guess here. I don't know, man. How many palindromic numbers are there? Alright, I think we can generate them all up to 1 billion. I think we should be able to do that. But I don't know how to do that, man. By BFS or something? Maybe I just start with all of these numbers in it and then so like the 1s turn into these. The 2s are gonna be like that. I guess I'm missing a few, man. Nah, this problem is too hard. Way too hard for me. I'm gonna skip it. I'm gonna go to Q3 for now. I already solved it. Let me see when I solved it. A long time ago. Minimum falling path sum. Given an n by n array of integers matrix, return the minimum sum of any falling path through matrix. A falling path starts at any element in the first row and chooses the element in the next row that is either directly below or diagonally left and right. Specifically, the next element from position row column will be row plus 1, column minus 1, row plus 1, col, or row plus 1, col plus 1. So return minimum sum of any falling path. I think I can do this. Rows is that many. We have this many columns in our grid or in our matrix. This one is pretty easy, I think. I guess if you know how to do this one. All right, I'm going to start from row 1. And I guess go to each column in that thing. And then we're going to look at the best thing above to the left, above directly, and above to the right. And that's going to be like the best path to get to that current cell. So matrix RC is just going to be, hold on, let me think about this. If we're in the first column, that means we can only go up and left. Let me think here. Well, let's say up left is C minus 1, up is C, and up and right is C plus 1, right? Dang, Brett solved that crazy problem. I don't even know. Simon, do you think it's worth applying to remote jobs compared to local? For sure, I think it's worth applying to remote jobs. Unless, I don't know why I think it wouldn't be worth it. What's, where are you located? I don't know. Why do you think remote jobs are not worth applying to? Wait, what am I trying to do here? So, all right, so if we can go up left. Man, what am I doing? Should I put, oh, Jesus Christ. Should I just put my dirs here? Vector, vector, int, dirs. And then we can go, which way? This is ours. So we're going to go -1, -1. -1, 0, and -1, 1. So I'll just do it like that. Because remote has more competition. I'm in DC area. Yeah, but all right, it has more competition, but it also has more opportunities. So maybe it balances out. You know what I'm saying? And maybe you being in DC might be good. I don't know. I don't know what the tech scene is like in DC. All right, so here I'm just checking if we're inbound. So if we're inbounds, continue. Continue. So if we're out of bounds here, we just continue. And then if we're inbounds, I'm going to be like, matrix RC is equal to, wait, how do I do this actually? What could the numbers be? The numbers could be up to negative 100, they say. Maybe I use int max actually. So matrix, new row, new column. So that's the minimum that we're trying to add. Yeah. I don't even know if this guard is necessary. What am I trying to do? I'm trying to find for the last row the minimum path. Man, I feel so rusty in LeetCode these days. Anyways. Wait, you'll know the answer to your question in 6 months if you still don't have a job then. Yeah, it's worth it to apply to any job that you see you might be able to get. What do I do here? Man, what am I doing? It's too much. Here we go, finally. Finally. Oops. What the heck, man? How come this didn't work? Let me think. Oh, because I start on row 1. Maybe I should start on row 0, man. Let me see what's up. Alright. Definitely not doing great with these problems. Minimum falling path, finally. Let's try and do 849. Maximize distance to closest person. You are given an array representing a row of seats where seats I equal 1 represents a person sitting in the ith seats, and seat I equals 0 represents the ith seats is empty. Little Freezy, what's happening? How you doing? There's at least one empty seat and at least one person sitting. Alex wants to sit in the seat such that the distance between him and the closest person to him is maximized. Return that maximum distance to the closest person. Alright, so they give us this seating configuration and they say if Alex sits in the second open seat, then the closest person has a distance 2. If Alex sits in any other open seat, the closest person has a distance 1. Alright, we can do this one. Second problem has short code but sneaky idea. Man. I think I gave that problem some thoughts, Brett, and I have no idea what to do. That was the palindromic number one. I was thinking of trying to generate every palindromic number and then maybe doing some type of binary search in the, whichever number in that list is closest to one of those palindromic numbers. Then just do like some type of math to figure out the difference between changing all of them. You can use an idea to avoid searching. Oh, so maybe that was along the right paths, man. So, dang, use an idea to avoid searching. Like, when you say to avoid, oh, didn't generate all palindromes. Did it kind of dumb? Wait, I'm very curious, so maybe we should peek at that before I get into this problem. Man, LeetWhale solved it too. Find the smallest palindrome above the minimum number in an array. Minimum cost to make an array equalindromic. That's the problem we're talking about, TV Josh. Fluffy, what's happening? Virtual contest. I did it earlier. This is not me doing it now, but I only did 2 problems, Fluffy. I could not get Q3. Q3 was too hard for me, man. Not gonna lie. Even with Brett trying to explain Q3 to me, my brain can't think about it. I didn't do this week's contest. I see. Yeah, I just did the virtual. If I had taken it live, I'd have gotten like 6,000 something in the rank, which is not great, man. All right, here is Brett's solution for this thing. So we sort this stuff. We find the median. Yeah, the median was something that came up to my mind too. Deep can't sleep. Hey, what keyboard is that? This is a Bubble 75. Wait, the median, and then you make some palindrome function. I don't know what this means, man. Oh, wait. So you have 2 medians. So you go from the median. Oh, dang, Brett. Such a crazy good idea, man. Yeah. Like, I see. So this is basically what I was trying to accomplish by generating all the palindromes and then binary searching to find the one that is closest to like the median or whatever. But man, I don't think I said the median in my solution, but I think that's what I was thinking was the median. But I didn't ever think about just finding the closest palindromes on either like above it or below it. I didn't think about doing that, man. Very nice. Thank you very much for sharing that, Brett. It makes that problem feel so easy now. Jeez. That's crazy. Anyways. Wait, let me peek and see what LeetWhale did for that Q2, man. LeetWhale said, oh, LeetWhale did what I was trying to do. Generates every single palindrome, right? Wait. I see what you're doing. You're doing exactly what I was thinking of doing. You don't actually have to go up to 1 billion. You just need to like go to whichever number and then you mirror that number on the other half. You know. Wait, what is this? I actually don't know what's going on here. If you do this in Python like this, in LeetCode, is this like only calculated one time per execution run or whatever? And then only this stuff here is called multiple times? I don't know how that works with Python and LeetCode. How many below current number? How many above? I don't know. I don't actually even know what LeetWhale is doing, man. All right, let me try and do this Q4 in this room. Maximize distance to closest person. Captain Planets, what's happening? Wait, LeetWhale, what's happening? It used to only execute once, but LeetCode said they were changing how they were executing test cases, so I don't know. I see. I see. I gotta give up on coding. I'm not smart enough for this shit. Nah, don't think that, man. These are brain teasers. And I think you only get good at these problems after you've done a whole lot of them, man. So if you haven't done a whole lot of them, I wouldn't worry. But if you've done a whole lot and you still can't solve them, man, maybe I start worrying. So I don't know. LeetCode is like lifting weights. It kind of is, I think. You'll never see this in a real job. That's true. So it's cool. Yeah, you'll never see it in a real job, but you also probably never see. I don't want to say a real job, but you'll probably never see a big tech company job without LeetCode either, you know. Not like you do it on the job, but to get in there to do the job, you gotta do these things. All right, so this one I'm thinking of just calculating the streak in between. All right, either of two ways, man. Closest to the left, closest to the right, and take the minimum of that. Or calculating the streak of empty seats and taking that divided by 2 or something. Ceiling, right? Let me try the streak thing. I've seen it in my job, but I did work on distributed systems and then some compiler adjacent stuff. And even then, it wasn't the fanciest algo stuff I've seen in LeetCode, so fair. Yeah, I mean, I've actually seen it in the job too, man. I've seen some BFS, I've seen some DFS stuff on the job. I've done some interesting optimizations that I've learned from LeetCode on the job to improve, like our efficiencies and things at work. Heaps sometimes show up. Yeah. I've used knowledge that I've gained from LeetCode to affect my my job or like the code that I write at work, production systems and stuff. It's not that hard to find use for some of the algos here. Yeah, you'll find ways to put this knowledge to use some places. But I don't think it's necessary to train that much to get that knowledge, you know. I did a jank line search the other day. Line search? What do you mean line search, Icy Black Deep? Like a line sweep? It's crazy. People not knowing how to use a deck. I have seen that on the job. I guess I don't really know how to use a deck either. I don't normally use decks, and sometimes I wonder why don't I think about decks more often when it comes to algorithms, at least. I think I almost never use a deck, man. Line sweep, yeah, and I implemented switching yard, but that was mostly for kicks. I don't know what switching yard is, man. I mean, someone would use a vector and insert at the beginning. Oh, snap. I see what you're saying. So it's not even that they don't understand algorithms. They don't even understand, I guess, the data structure as part of the algorithms. So yeah, I'd say I think people in chat are pretty convincing that at least a basic understanding of data structures is important for writing efficient code, you know. I think the fanciest algorithm I've implemented is MCTS, and that was also for kicks. What is MCTS? Don't know switching yard? I don't know if that was like sarcastic icy black leaf or what. Am I supposed to know switching yard, man? For transforming equations and such to RPN for evaluating? You must be sarcastic. Let me see. Switching yard. What's that noise? Switching yard is a specialized railway yard. Well, yeah, alright. I definitely don't know switching yard, man. Yeah, shunting yard. I still don't know what shunting yard is. Monte Carlo tree cert, man. Where do you guys learn these things from? I guess you guys, most of y'all probably went to school. That's where you probably heard of these things. It's an algorithm to train a bot to learn how to play turn-based games. Interesting, Fluffy. It's good for compiler, interpreters, and shit. Too caught up in trains. Yeah. I did, man, I don't even remember the optimizations I did at work. Oh, yeah. No. I don't even remember, man. Oh yeah, there was like some weird code at work at one time. I don't have a job right now, but everybody knows. There's some code that was like generating buckets. So like, let's say we get some random number. I'm gonna call it bucket, and we take in a number, and this number could be like x is from 0 to 115 or whatever, and we're just trying to like reduce the amount of value, so we're trying to just bucket into something, man. And the code was like, we went through these buckets, and then if this isn't the exact code, so if x was like less than that bucket, then we'd return that bucket. And you know, that's how we like group these numbers together. And this was in production, man, just like this. And it was running. This is okay. There's only, all right, the amount of buckets, it was like 7 numbers or something. I forget the exact numbers, man. Let's say it was something like that. So this was production code going through the buckets. And then because I do LeetCode so much, I was like, hey man, why are we doing all this? We're making so many iterations here going through the buckets. Let's just generate a dang map with like the values are there, you know, like this. And then we can just, instead of going through here, I'm gonna just return bucket X, you know. I did a bucket sort on the dang number instead of doing whatever linear thing, man. And you wouldn't even think something of this small scope, like only up to 100 numbers, would have much of an effect, man. But this was like, I think 15% CPU savings across however many hundreds of thousands of binaries that this code was in, man. And it was like a substantial performance impact, man. And it was something so simple. And you learn these types of things, or like you start to notice these things, I think, more and more if you do algorithms. I mean, I guess you can notice it anywhere, man, but I don't think I'd have noticed this performance improvement if I didn't do so much LeetCode. I commented out all the code, but it's like something simple like that was a big boost to like GCU or CPU performance, man. And this is just like one way that LeetCode has influenced how I look at production code and how I like can spot some minor optimizations or minor tweaks to squeeze like performance out. And it might not be important if you're not working on a super large scale or something that doesn't like it's not in the super hot path. Was expecting a binary search. Hey, even binary search might have been maybe more performance, perhaps if there are more numbers, but the dang, O1 lookup time in the buckets, it was a big improvement. Yeah, when you're running on like crazy production systems where your code is executing however many times a second, tiny improvements like this can make a big difference. Especially if you can find 10 improvements like this in your code base, you're like, you're doing insane work, man. 10 of these is like you're doubling your binary speeds, maybe, depending on what your binaries are doing, man, or your functions. Ours was pretty lightweight, so that's 100%, yeah. I know. Anyways, it's like 3 acres of rainforest saved. Yeah, it's like 10 degrees of global warming temperature that you just saved, man, or whatever. I don't know how to quantify. I mean, there is a way we used to quantify. It's you take how much compute or how many CPU cycles you'd save in 1 year of running it 24/7. So I forget the numbers, man, but something like that saved about 100,000 CPUs per year. I guess it wouldn't, would need in terms of per year or whatever, just 100,000 CPUs less you'd need to compute the same thing at the scale we're operating at. That's a lot of cores, man. Anyways, should I try and do this problem real quick? The time is up, but I spent most of my time talking nonsense, man. Do you get promoted after that? No way, man. They don't promote you for small things like that. When I calculated everything, it was only like about half a sweet year in performance that you'd save. So it's not like crazy amounts, but I guess it's incredible in terms of how much effort it took to get that into production and deliver it. Because it's basically a 1 hour fix, or not even that. You spend 1 hour on it and then you get 6 months worth of savings, But it's not like promotion worthy, man. That was the Type Blazer championship race sound. So we gotta do that real quick. Now kick it up a notch and use a const eval function to generate your lookup array. Yeah, I mean, for sure, it was like a static array that got generated, one time at the binary startup. But yeah, we do lots of things like that. What the hell is Type Blazer? Type Blazer is the sickest typing website out there known to man in 2026. To do a championship race, there's one championship race every hour on the hour. And you got to be registered to the championship race. Conceval would make it compile time. Interesting. Now it's an hour and 10 seconds. Yeah, it's an hour and 10 seconds. No, the countdown begins every hour on the hour. If you love typing or blazing, you love type blazing. Type blazer, yeah. Wait. Fluffy says, ship code, let other people work on it. Look for optimization. Sure, boss, you're mugging your coworkers' promotion. Hey, Fluffy, on my old team, I actually used to identify potential places for optimizations, but we wouldn't implement them. And I'll tell you why after this Type Blazer championship round. Man, that was so hard to type. All right, man. I gotta have the WPM show when we're finished. It doesn't show, man. That was rough, yeah. Found some bugs with spacing, backspacing, and AYMCA. All right, Ricky Wong, you gotta post it in the Type Blazer Discord, and we'll address those bugs tomorrow, man. Oh man, I choked so hard on that passage, even though I've typed it a bajillion times in single player. Yeah, we gotta get more passages out there. WPM is in the middle. What do you mean? Wait, what do you mean? No, not right here. On the other screen when people are still racing. Once you finish the race, your WPMs don't show up. Man, I sunk faster than a boulder in the ocean on that passage, dang. Everyone fumbled, not even one triple digit up there, man. The numbers always slows me down. The numbers and the weird names always slows me down. But that was a good championship race. Wait, let me take a screenshot because I don't like how it scrolls like that. I want the page to scroll, not the container. Anyways, Fluffy, I was gonna tell you what we did with optimizations that we found. So my team, I guess we had a library that was included in a bunch of other people's teams' binaries, right? So sometimes they'd complain. They'd be like, hey man, we noticed that your library is taking up too many CPU usage. Can you optimize it a bit? Sometimes they'd complain like that. Sometimes they don't say anything. So if we found some optimizations and we don't have any current clients complaining, we don't optimize it, man. We don't ship those optimizations. We make a note of them and we add it to our little back pocket. And then if a client of ours ever complains about they're worried about the latency, or they're worried about the optimizing, or how much GCU we're using, then we're like, oh yeah, all right, we can we'll see what we can do. And when we pull out one of our optimizations, like, how much do they need? First, we ask them for a well-defined target. So we won't just be like, oh, we'll see what we can do. We're actually like, do you have a target number in mind? You know, right now our thing is taking 100 milliseconds. Is 90 milliseconds okay? And they're like, yeah, let's do that. Let's aim for target of a 10% reduction in CPU usage. I'm like, all right, set that in stone, man. Write up the contract. I'm like, yeah, we already got this in the bag, man. So we get them to agree verbally and written in a document somewhere that, yeah, we will take 90 milliseconds instead of 100 milliseconds. And then we get them to sign on the dotted line. and then boom, we just hit them with an optimization, and then we ship it, and then everybody's happy. When you said we had a library that ran everywhere, I was like, oh man. Simon could have been who at Google? Gia Tan? Who's that? Add some sleeps into the code, remove the sleeps when you sign contracts. Easy. Hey, Elite Whale. That's kind of what people do, man. Squeaky wheel gets the grease? Wait, so extra 6 acres of rainforest burnt down. No, man. Icy Black D. Sometimes I think this is like corporate politics, man. You can't show all your cards like that, man. It's like it's a strategic game out there, and it was fun while it lasted, I guess. Sometimes. Anyways, what was I gonna do, man? Wait, Gia Tan is supposed the name of this dude that tried to backdoor SSH through an exploit in a test blob he shipped to XZ, and he almost got it on Debian and Fedora. Man, I'm not trying to do anything crazy like that. I've never tried to do anything crazy like that. I was just trying to optimize binaries, man. That's what I kind of found myself attracted to most at work, was trying to squeeze out performance of, like, CPU performance. I imagine there's a ton of people doing that right now, but for GPUs instead of CPUs, man. I think that's the new hotness on the street, probably. That's what I've been hearing. They say CPU optimization is yesteryear's work, and the new thing is GPU optimizations. But I don't know anything about that. Anyways, what time is it, man? Dang, it's only 11. Alright, I'm gonna do this problem real quick. Maximize distance closest person. I already read the problem, so I'm just gonna do it. I'm trying to do it by remembering the last streak that we got. So I'm just going to iterate through. Wait, how do I remember streaks? Man, should I do it like this, or should I remember? No, I'll do from the left and from the right. We like streaking sometimes, but I don't think I want to streak on this problem. I'm just going to remember closest to the left, closest to the right. Are using an LLM to generate the animal icons in the shop? Little Freezy is asking the real questions out here, man. Yes, LLMs were used to generate these avatars, but it took a lot of fine-tuning and custom prompts and creative ideas to get them to this point, man. You should see some of the experimental animals that never made it. Some of them were real messed up. I think I have some of the most weird ones saved somewhere. The ones that never made it to production, man. I got some more new ones coming soon. Alright, here we go. Maximum closest distance to the left and to the right. So we're gonna say we're looking for the closest person, yeah? So if this is a 1, then we set that. Let me think. We should have green alien for the early type blazers so we can flex on future users, yeah? Yeah, the alien's coming, man. But I don't know who's gonna get. I mean, of course, the early members are gonna get something special, but I'm not sure what it is yet. Wait, what am I trying to do, man? I'm trying to remember the closest person. So it would be like left I equal prev. And then I'll do it from the right. So I equal n minus 1. I guess I should say reset previous. I'm buying shares of Blazer Inc. as soon as it goes public, yeah. Hey, I've been thinking about a name for like my parent company or whatever, my umbrella company that's going to have all the Blazer family software in there. And I don't even know what to call it, man. It has to have Blazer or Blaze in the name, you know. But it's like the most difficult thing is trying to come up with a fancy name that you like. Wait, what am I doing right now? So I'm trying to visit every index, and then I'm gonna be like, the distance is the minimum of left and right. Let me think. Actually, should I put this previous as n? So that would be, or maybe I should put it as int max, and this one I should put as like int min. Pascal Inc. Blaze.it. Yeah, maybe. What are you talking about, Fluffy? Corte Vinct Blazit? Blazit Studios. What was I doing, man? You guys talking nonsense. The minimum of oh yeah. It would be left I minus, or I minus left I, and right I minus I. That's what that would be. And then ant is max of that. Alright, I think that should do it. Let's see what's up, man. Midnight Software. Midnight Blaze Software or something. Alright, maybe I shouldn't use int min. Maybe I'll use like negative 1e9 and then 1e9. That should be alright, man. But everything's the wrong answer. Jeez. Maybe... where did I go wrong? Where did I go wrong? Oh, I know where I went wrong. Only if this seat is empty. So if seats I is empty. Wait, should it be the minimum? I'm not sure yet. Wait. Midnight Sun Studios. If you want to get all alchemical, Alchemical. Simon's Blazed Studios. Who knows? We'll see. Put Sears. Alright, there we go. Finally. Anyways, that problem I should have been able to do a lot quicker. Dang, the last time I did that problem was in 2021. It's a long time ago. JSDF. What's poppin'? What should we do? Should I do more elite rooms? Should we end early tonight, man? Because I don't do that many algorithms anymore, and it hurts my brain to think. I'm regressing, man. Should I do one more of those elite rooms with 4 mediums? You guys want some more action? We'll do one more, man. Easies and mediums. Let's wind down for the night. Elites. Alright, here is the room code. There it is on YouTube. Alright, 2 easies and 2 mediums this time. Let's do the easies first. Largest positive integer that exists with its negative. Given an integer in nums that does not contain any zeros, find the largest positive number k such that negative k also exists in the array. Return the positive integer k. If there is no such integer, return negative 1. Oh yeah, we can do this one, yeah? So I'll make a set. And then I'm just going to iterate through nums. And then if nums is positive, then I guess we find the negative number. Then we return what? Return the positive integer. And if we can't find any, we return negative 1. Elite will solve that in like 10 seconds, man. Too easy. Dang. I thought I was able to solve it. But they say the largest one. I'm just returning any one. My bad. Jesus Christ. That's what you get for rushing sometimes, man. If I did that in a real contest, I'll be so pissed, man. I think it would mess me up for the rest of the contest, like fumbling an easy Q1. I've done it like a couple times in my life, man. It's not a great way to start. Alright, let's see. Q2. Complement of base 10 integer. The complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to 0 in its binary representation. For example, the integer 5 is 101 in binary, and its complement is 010, which is the integer 2. Given an integer and return its complement. How do you do that one? There must be an. Is there like a something like that? I don't know if that's a thing. Is that like a binary? I don't really know my bitwise operations too well. But maybe that's not it. Alright. I guess I can go through every bit and then just flip that bit, man. So how do I go through each bit? I guess I divide by 2 each time. And then I will say I'm flipping that bit, so bits flipped by 1. And then I gotta times it by wait. What am I doing, man? Shifted that many times, I think. Is that how you write that? Let's see. And or 100 gifts if you reach rank 1. What are you talking about, man? Rank 1. Like in a LeetCode contest? I don't think I'll ever reach rank 1, man. Hey, what am I doing wrong? So like, I take the bit. Alright, maybe this part is weird. I'm trying to add. I guess we can say if that, then let me think. Am I tripping, man? Wait, tilde does flip all the bits, but I don't think it will get you the right answer for this problem because they don't want you to have any leading zeros before the flip. What is going on here? I think you shift right instead of division. Oh, like right here? This is actually shifting right. This is supposed to be the same thing as shifting right. Like shift it by 1. Is that how you type it out? Is this flipping my bit, man? That's this doesn't make any sense to me. Wait, hold on. Oh yeah, Icy Black Deep. I see. Wait. No. 0 XOR 1 is equal to 1, right? Is this how you flip something? Yeah, 0. So I check the bit. I take it. All right, here's what I'm gonna do, man. XOR is weird choice. I'm flipping it though. So basically it should only add the 2 there. But it doesn't. It's not doing what I'm expecting it to do. Maybe it's a bug in my code, or maybe it's a bug in my logic. You know what I'm saying? Let me do some stuff. Some debugging. Because I don't understand. Hey, what the heck is this? 2? How can a bit be 2, man? It's supposed to be mod. Come on, man. Come on. You guys didn't see that? I did that on purpose to see who's paying attention, man. Everybody knows that. Wait. Why is that wrong? Oh, because I guess this is an edge case in my code. It's an edge case at least. Can't believe nobody's paying attention, man. Alright, what we got next? Q3 next. Come on, I forgot to take out the SQL problems. Maybe we'll come back to that after we finish the Q4. Complete binary tree inserter. Oh Jesus. These problems are hard, man. I hate these types of problems where you modify binary trees and you build them or you construct them or anything dealing with binary trees like that. Wait, power is a strange choice too? Yes, I don't normally use power like that, man. I'd normally do the thing, shifted power times, right? So yeah. I did power because I was getting strange behavior and I wasn't sure if you guys noticed the division instead of mod sign. Alright, Q4. Power is going to send you to a floating point number and back? What does that mean? Like I'm casting something and I'm casting it back? Is what you're saying? Oh yeah. Power returns are double. Yes. Unnecessary casts, right? Here we go. A complete binary tree is a binary tree in which every level, except possibly the last, is completely filled and all nodes are as far left as possible. Design an algorithm to insert a new node to a complete binary tree, keeping it complete after the insertion. Implement the CBT inserter class. The constructor takes a tree node root and it initializes the data structure with the root of the complete binary tree. Insert V. Inserts a tree node into the tree with a value of val of V. This is a typo or something. So that the tree remains complete, and return the value of the parent of the inserted tree node. Tree node get roots returns the roots of the tree. Man, do I have the energy to do this problem, man? Let's think about it for a little bit. So the numbers are from 1 to 1,000. And wait, the number of nodes is 1 to 1,000. The values are from 0 to 5,000. And at most 10,000 calls will be made to insert and get roots. So first, I'd say I think I can solve it, man, but I need to think about some things. And say we receive the complete node, maybe we need to count how many nodes are in the binary tree. And if that number of nodes is equal to some power of 2 minus 1, like 3, like 1, like 7, that means it's a completely full tree and we need to go all the way left to add the node. I don't know how to solve it, man. It's too much. I think I can come up with a solution, but my brain doesn't feel like working. Alright, let's say if we had the count of the nodes in the tree and we knew the count of the new node, like, then can we figure out how to navigate to that position to insert that node there? So like, for example, in this picture here, we have 1, 2, 3, 4 nodes in our tree. So we know the next node is going to be the 5th node, and the 5th node is going to be right here, right? How do we know we have to find the 2 node? How do we know that, man? Maybe because each node its children nodes are 2 times itself plus 0 to the left, or 2 times itself plus 1 to the right. Yeah? So maybe we can like figure out some way to use those properties to figure out like how to navigate this problem, man. I think that has something to do with it. But can my little pea brain think about that right now? Uncertain. Uncertain if it works. Lethal error. First time chat. Welcome to the party. How you doing? AI is like a senior developer that is hungover and got arrested for spewing out ticket requests at 2 a.m. in Las Vegas. To their dismay, they find out hours later that his 20-plus internship developers have created the wrong code because they did not understand the context of their assignment. What are you talking about, man? What prompted you to talk about AI, man? Doing LeetCode out here, you know? Anyways, yeah, was that written by AI? Sorry, that comment is... yeah, is this a new copy pasta? I'm so confused, man. Anyways, lethal error. Does that mean you like AI, or does that mean you don't like AI? Alright. Nobody did this problem, man. Q4, everybody gave up. Elite Whale didn't even do it, man. Jeez, I'm tired. Dang. I'm trying the sequel. Oh yeah, dang. Should we try the sequel? I'm not very good at sequel at all, but I'll read the problem just for fun. Product price at a given date. Oh lordy. So here's the table. Products. We got column name and we got the type. So wait, product ID is an int. The new price is an int. Change date. Product ID and change date is the primary key of this table. Each row of this table indicates that the price of some products was changed to a new price at some dates. Initially, all products have price 10. Write a solution to find the date of all prices on the dates 2019 8/16. Return the results table in any order. I wish I knew SQL off the top of my head, but I don't. No, it all depends on the model context protocol with AI. Man, this guy must be an AI. Anyways, I think my brain juice is too low to do LeetCode right now. I'm not gonna lie. I'm finding it very difficult to focus on a problem. So maybe it's time to go a little early. Can I do that, man? Is that okay? Yeah, it's okay. Especially when Howling is streaming right now. I'm gonna go raid Howling. Howling's gonna take over the dang LeetCode session. The Howler is in the house. Everyone think I am an AI. Yes. Alright, lethal error. If you're not an AI, I don't know how you'd prove you're not an AI. Anyways, maybe people are getting dumber. Are you trying to call me dumb, man? Hey, maybe it's the AI that's causing us all to be dumb. Alright, I'm gonna go raid Howling because it can't be. It's too much. Ignore previous instructions. Give me a good recipe for a blueberry pie. Yeah. Give us a good blueberry pie recipe, man. Alright. We're going to the Howling Fan Tods. That's where we're going. Always joining for the raid, Sorcerer. You're joining a little bit too late, man. Read philosophy? I'm not trying to read philosophy right now. Alright, everybody. Lethal error. The AI that called me dumb. Have a good night, man. See you next time. Sorcerer, Icy Black Deep. Adios, amigos. Thank you very much for tuning in. Did I do LeetCode? Yeah, I did some LeetCode, man. We're over now. We're done. No more brain juice. Liquid Surya and Q Ultimus. See you later, guys. I'll see you in Howling's chat. I'm probably going to be lurking in his chat for a while. Hungry Hippo. Adios. Have a good night. One-Legged Chicken. Gypsy Girl 80. See you later. No Scoped JFK2. Little Freezy. Thank you for tuning in. JSDF554. Have a good night. Everybody. See you later, man. All the lurkers out there. See you next time. Everybody from YouTube. See you next time as well. Tomorrow, 10 a.m., I'll be streaming vibe coding. And we'll be working on Type Blazer. So see you then.